there, so what are we gonna do?
Accept the null and reject the claim.
Accept the null, reject the claim. That, I'm gonna write it out this time. That there is a difference between the mean test scores of the classrooms. Okay, now what we're going to do is we're going to quickly do this in our calculator and make sure we can. So everybody hit stat, tests. What do you think this is going to be?
Probably two sample t-tests.
2 sample t-tests. Are we using data or stats?
Stats.
Good. So let's type it in, 473, 39.78. Should be not equals to, should be selected. Do you see how it says pooled, yes or no? So what do we say?
No.
No, the variances are not equal, it is not pooled. Then you must not have typed in your numbers right. Go to stat, tests, and then compare your calculator to the screen on Coles.
Oh, I see where I should.
How do we know the degree of freedom again?
In this case, the degree of freedom is the smaller of n1 minus 1 or n2 minus 1.
So it's always just the small one?
It's not always. It is when the variances are not equal. So that's right here it was.
Okay.
The smaller of n1 minus 1 or n2, but the other one, it's you add them two together and then subtract 2. Because we're kind of pooling their variation together, so we're adding them together, subtracting 2 for that degree of freedom. Because you know how we always subtract 1 for the degree of freedom? So when you add together, you subtract 2, but anyway. All right, let's try again. This time we're doing the hard one, the gross one. Ready to be gross?
Always.
And then your homework is a total of 4 problems, 2 by hand, 2 by calculator.
By hand.
Manufacturer claims that the mean operating cost per miles of its sedans is less than its leading competitor. You do a study of 30 random selected sedans, 32. The results are shown below. Of course they're not. Gosh, I suck at this. All right. All right. This is our manufacturer, and this is their competition. So for our manufacturer, their X bar 1 is 52 cents a mile. That's how much it costs to run this car. And their competition is 55 cents a mile. All right, well, we did our job. One's less than the other. We can just quit now, right?
Yep. Mm-hmm.
The standard deviation of the first is 5 cents a mile. Standard deviation of the second is 7 cents a mile.
Do we have to label all our numbers on like the AP test?
Yes, you have to label every single answer on that one test that matters that one day, Gustavo.
No, like all the miles and stuff too. Yeah.
Yeah.
Okay.
It's better to overdo it than not do it.
Right. And again, it's just once. Do you have to label every single little thing on every single little homework assignment for me? No. But on the AP test day, that's the day where we're really going to go for it.
Oh, let's check.
Maybe you want to label your label. This is the title of my graph. I'm also going to write the word title next to it, just in case. Why not? Why not? Nobody's gonna get mad at you for writing extra things. Okay, so here we go. Results are shown below. They are now. At alpha equals 0.04, can you support the manufacturer's claim? H sub O, H sub A. Makes you almost miss one sample hypothesis testing, doesn't it? Oh, good old one sample hypothesis testing. You guys know how it is. What's the claim?
It's a less than.
Less than,
Which is the alternative. Is everybody good on figuring out alternatives? And it is left-tailed. Want to use rejection regions again?
yes.
How do we figure out the rejection region?
Look at your teach.
Wait, this one or no?
We are going to do it both ways.
So you have to do, I don't have it written down, but it's
We
N
do
one
N1
plus
plus
N two
N2 minus
minus
2.
two. So
Mhm.
30 plus two minus two,
60.
which is
60. Okay, so we're going to go on 60. What if, by the way, what if you ended up with 62, 63? It's not on the list.
you'd be wrong.
No?
I don't know.
Go to the
Just
nearest
round
one.
down.
Go to the nearest one. Because if you really look at the difference between 60 and 70,
Oh, there's-
yeah, that's why. It's not that it's too cumbersome for them to write. It's because there's just not a lot of variation.
If it was 65, would you?
500 to 1,000 is, do you see how they're
You
ending
go in between.
in the 1.645 and 1.96? See, they're getting closer and closer to the rejection regions as they would be with z-scores. Okay, so we're doing a one-tailed test. And what alpha's in that tail?
5%.
5%, so I'm looking at the second column here, down to 60. I'm seeing 1.671, negative, because it's on the left. All right, here we go. It's gonna be so gross. 2 big square roots, nobody wants them. All right. X bar 1 minus X bar 2 is 0.52 minus 0.55. Who was it who asked me? Was it Caitlin this morning? Who asked me, does it matter if you switch the 1s and the 2s? It doesn't matter which one you call the 1s and which ones you call the 2s as long as you're consistent. You can't switch halfway through the problem. Like if I said X bar 1 minus X bar 2, and then I labeled the competitor with my S1, that wouldn't work. So they're all 1s or all 2s. That make sense to you? Okay, so 0.52 minus 0.55, and then underneath is N1 minus 1. So I'm going to say 29. I could write 30 minus 1, but I'll just write 29. Times the standard deviation squared, so 0.05 squared over, and then there's what, plus? The N2 minus 1, which is 31, times that variation squared over 30 plus 32 minus 2, which we said was 60, right? So do you see how I'm just kind of doing some of the math in my head? Instead of making it, because it's going to be really hard for me to put all that stuff in a calculator if I don't just do some of it myself. Times, and this is 1 over n sub 1, which is 30, plus 1 over n sub 2, which is 32. So if you do some of the little subtraction stuff in your head, it's not so bad. All right, we can do it. Here we go. On the top, parentheses, 0.52 minus 0.55 divided by parentheses first. Because I don't want it just to be divided by the square root. I want it to be divided by both square roots, you see? So now I'm going to hit a second square root. Let's see if this stuff will work out by itself. Nope. So the top is in parentheses. 29 times 0.05 squared plus 31 times 0.07 squared. Parentheses divided by 60.